First question, who's come to the Avalanche Summit in Barcelona? Okay, this is great news, because this is an updated version of the talk that I gave at the Avalanche Summit, and it's about subnets. So it's about a hot topic right now. And I'm really happy and excited to be here today. Here in Berlin, I went to go-karting first and then doing some simulations. I hope you do it because it's so fun. But here, looking around here, I feel like we're at the verge of the latest trends in technology. And all of us here, I believe, think that Avalanche is poised to become the winner takes it all in the crypto economy. Some of you may know me, some may not, but they most likely know the project I work on that is called Avascan. 2022 is the year of subnets. We all know it. Avalanche has made that very clear. And in my opinion, but maybe not only to me, the ecosystem will grow insanely. We're already seeing it with the 4 new subnets launched in just over a month. And we at Avascan were preparing this for a while. We rushed it, indexing every new subnet that it was coming. And it all starts with understanding what a subnet is and how it's related to all the other technology that's on Avalanche. So this talk is about answering the question, what exactly is a subnet? As you can see in this image, and as you surely know, there's mainnet, which everyone is using, and there is testnet, also called Fuji, that's mainly used by developers to test their application before launching on mainnet. These are called networks. Inside every network, mainnet or testnet, subnets can exist. The first and most important one is the primary network, previously called default subnet. I hope they call it the primary subnet because it's more coherent. Every subnet is basically a committee that is composed of validators that validate the transactions of the blockchains in that subnet. Every validator can validate one or more subnets, but it must validate the primary network as well. So the primary network is actually the biggest subnet, and it validates 3 chains: P chain, X chain, and C chain. If you came to Avalanche during DeFi season, you most probably only interacted with C chain, while if you got AVAX in ICO or used it from the beginning, you most likely have interacted with all the chains at some point. As you can imagine, the subnets and the multiple blockchain design gives Avalanche a really complex structure. Theoretically, tokens, both fungible and non-fungible, can travel between blockchains and subnets, realizing what we may call the subnets economy. Subnets economy can be described as an economic system in which value moves from one jurisdiction, for example, like subnet, to another with high interoperability in the same distributed network. We will start seeing some of the dynamics of subnets economy in the coming weeks. We are really starting to see something right now. As new subnets are deployed to mainnet and bridges are made to connect them with each other and with C chain. Each blockchain then is the combination of 3 modules. It can vary greatly. For one, a blockchain needs to be validated by a subnet, but a subnet can have 1 validator or 1,000. The second one is the Genesis block, which is the Coinbase at launch with some minting parameters. And the third one, the most important one actually, is the virtual machine, the operative code of blockchain that is powered by a consensus engine. Currently, there's only Snowman++ and Avalanche. There are many VMs running on the Avalanche platform. That's called Platform VM, AVM, EVM, Timestamp VM, and many others. VMs are, in a word, heterogeneous. And this subnet structure has many implications because heterogeneous VMs powering custom blockchains validated by different subnets can have multiple implications. Showing correctly what's an address, for example, is very hard when each VM could have its own implementation of address. The key word here, remember, is heterogeneity. Remember this, networks, for example, Avalanche, contains subnets that can have different rules, which validate blockchains that have differences from one another. This is one of the thousands of emails that we received in our feedback email address in the past 12 months. It generally involves a user sending a token from a centralized exchange to his wallet, but then finding out that the token he sent is actually the wrong one. And this one only transferred 0.56 BNB, but there are people that lost thousands and thousands of dollars. And we need to find a way out of this. This is the root cause of our continuous research, to simplify the complexity to newcomers and early adopters. For those of you who don't know what Avascan is an explorer, is the Avalanche Explorer, the alternative one to the one developed by Avalabs. And we basically continually ask ourselves these questions. What is this data? What can we do from it? How can we say it? How can we explain it to the first billions of people? And a lot of what you see right now on Avascan is not what it will look like in a month's time or even a week time. We are iterating 3 times per day, and we are really working day and night on understanding and making few tweaks as many times per day as possible to understand how to improve the overall interface. This is another example of people that are really confused about what a token is. This is not a problem anymore, but it was when I first screenshotted it in March. And USD, that is now a really sad story, was bridged to Avalanche via the Axelar network, but then Avalanche made an agreement with Terra, and so USD was deployed natively, but the 2 tokens would not have the same actual value, and so you would not be able to do the same things with both tokens. Because with the Axelar token, you could trade it on Trader Joe, but then you could not deposit on Anchor. With the other one, you could not deposit on Anchor, but you could trade it on Trader Joe. It's confusing. So it all starts with understanding what an address is. The address is the simple string that contains everything, and we will make a journey. Even the term address is actually ambiguous. With address, we're trying to define a concept that actually means different things based on the context. Like I said, Avalanche is agnostic by design, and a developer can deploy a blockchain with a virtual machine with its own transaction model, with its own rules, etc. For example, Platform VM, the one behind pChain, is a Platform VM virtual machine with a Snowman++ consensus model in a chain of blocks. Avalanche VM, the one behind Xchain, as an Avalanche consensus in a DAG, that is direct acyclic graph. While EVM, the one we all know, the one behind C-Chain, as an accounting model and a Snowman++ consensus protocol. Let's also look at some of the new VMs that are deployed in the last month or so. The FK chain as a DeFi Kingdoms virtual machine that is actually pretty 99% equal to the EVM, and so it's C-Chain, and also the Swimmer network as a really, really similar structure. But this is not we cannot make it obvious. For example, there's another blockchain that has deployed in, I think it was last week, and we are already talking with them. They're actually based on Zcash. So the accounting model and the transaction model are different because they're not based on EVM, they're based on zero-knowledge transactions, and so there's going to be a whole different. So for example, let's say in the UTXO model, we can call an address an owner. We do not call it an address. While in the accounting model, we call it an account, because it's actually different things. While we can generally refer to them as addresses, they're in fact very different nature. The map you see right now is a simplified, really simplified version of our research work in understanding how addresses work and how they relate to each other. I will not dive into the specifics of each one of these entities because that's not the focus of the talk, but we can briefly pass on to the most relevant ones. For example, an address on pChain that is an owner can belong to the Genesis set, which is what we call the subset of addresses that was included in the Genesis block, hence received AVAX at mainnet launch, either vested or unlocked. But an address can also represent the treasury of a dApp or a centralized exchange wallet. On C-chain, EVM, addresses, specifically known as accounts, can be smart contracts. And the difference is that smart contracts can run custom code, while addresses, accounts, do not. There are a lot of different types of smart contracts, mostly based on development standards in the crypto community. For example, there's the NFT collection that is based on the ERC 721 standard. There is the factory and the router contracts that are the foundation of every DEX based on Uniswap. And then there's a liquidity pool token that is actually a kind of fungible token that actually can contain tokens and is generated by the factory contract. And there's also the liquidity staking receipt, if you, for example, do liquid staking on Banky. And if there's also maybe the auto-compounding receipt, there are a lot of types of tokens. And those tokens can be smart contracts, and the smart contract addresses. You see what I mean here? It's a lot. The most important one is the token, as the ERC20 standard. And this is just the beginning. This is just, what you see here is just a little bit of what we know it's recurring in dApps and projects. But this is a continuous work. And we hope this could be just the beginning of a major ecosystem-wide effort to make a sense of all of this for the next generation of users coming into the industry. The concept of token, as I said, is the checkpoint of our brief journey. From here, we will dive into the different natures of a token and how you can distinguish them. I'll go into detail using a sample token to make things easier to understand. First, I need to a little bit sip. Let's take AVAX. We all know it, and it fits really well in most of the concepts. We'll follow AVAX's path as we virtually move it across subnets to learn how it changes and when it comes back to its native place. AVAX is minted on P-chain, the primary network. That means you only need to trust that its deployer, Avalabs, has done a good job in building it the right way. Here, so when a token is native, you only need to trust the protocol itself and the team, community, or individual that developed it. There's a direct connection between you and who actually developed the token. Let's take AVAX and transfer it with the help of the Avalanche wallet on X-chain. Most of the users that bought AVAX in ICO got it on P-chain, then transferred it on X-chain to spend it or move it to an exchange to sell it. This is a pretty standard procedure. Now, let's take AVAX and transfer it from X-chain to C-chain, the busiest blockchain on Avalanche for now. When we transfer AVAX to C-chain, it's a slightly different token because it's not an X-chain anymore. For example, Binance accepts AVAX deposits both from X-chain and from C-chain. But it can change even more by wrapping it. Before interacting with smart contracts, AVAX must be wrapped in a special contract to fit it in the ERC20 standard. This is something that I saw also on Twitter. There's a lot of confusion between what is wrapped and what is bridged. Beware, wrapped does not mean bridged. Wrapped means I take a native token, I wrap it in a ERC20 standard. The wrapped token can then be bridged. A bridged token is also wrapped, but a wrapped token may not be bridged. This is also, I saw some media outlets having some explanation about this. It was really confusing. But please be aware that wrapped is one thing and bridged is another. So this wrapped token is called wrapped AVAX. We actually, Avalabs has a different symbol for it. It's really good that it's a different symbol and also a different logo. A wrapped token is manipulated by a smart contract to adapt it to another standard. There's software involved that changes the structure of the token. It is also changes its symbol because it's WAVAX. Its name is wrapped AVAX, its symbol is WAVAX. And this is really subtle, since AVAX is liquid on centralized exchanges, While wrapped AVAX is liquid on decentralized exchanges, it could even have a little different in price. Now let's say a new subnet called Barnet is offering huge incentives to move the tokens in its food chain in terms of reward boost or free tokens. This will be happening with the Avalanche Multiverse Incentive Program, and it's already happening with DFK, for example. You want to move your wrapped AVAX there, and you can do it with a bridge. This is already happening. And you can do it with a bridge. A popular EVM bridge is chain bridge. You can connect EVM chains across different subnets or across different networks. Bridges can be two conceptual types: internetwork, such as the Avalanche bridge connecting Ethereum to Avalanche, or intranetwork, such as bridges connecting different subnets. Or if we are going to say about, maybe the Cosmos ecosystem or Polkadot connecting different parachains or different blockchains in the IDS ecosystem. The two methods are actually different in nature. Maybe the software involved is the same, but the concept is different. Because with the first method, you're going outside the network, while with the second one, you're still inside Avalanche or inside the network, inside the ecosystem. When token lands on a new subnet, transactions will be validated by a subset of validators. So take that into account. While if you bridge it from Avalanche to Ethereum, you're actually trusting two different sets of validators of nodes. So if you trust the Avalanche validator, remember that if you go from Avalanche to Ethereum, you are trusting actually a different set of validators. And as for changes in the structure, we don't know cross-subnet dexes yet. So the token price and liquidity may change if the token is bridged from one subnet to the other. And then there can be many types of bridges, as you can see here, and this adds to the overall heterogeneity. I could have made a deep dive into bridges, but I thought about two things. The first one is that, we actually don't even know about the real differences between all these two bridges right now. And the second thing is that we don't even know what the consequences are of bridging between two different bridges in the same network. So maybe for another event in a couple of months or something. Here's a table to recap all of this. Remember, an extended version of this talk is already live on our blog on blog.avascan.info. So it's there if you want to dive into that later. So we had AVAX on P chain. Then we transferred on X chain and then on C chain. And there's no change in symbol, price, or limit liquidity. Since the token is on the same subnet, the trust model doesn't change. And then on C chain, we wrapped it into wrapped AVAX. The symbol changes, liquidity is changing because it's provided on different markets, and price may therefore change slightly. Then we bridged wrapped AVAX onto another chain or on a different subnet, and that changes a lot. The symbols should change to distinguish it. Price and liquidity will change because it's traded on different markets, and the trust model changes greatly. You now need to trust the bridge manager and the subnet validators. A lot, huh? But to make things even more difficult, let's take another example really quickly, an example that should not happen. And please don't let this happen, Let's take Wolfie, the Avalanche meme, so we don't offend anyone. So let's imagine we use a sample Wolfie native token that we deployed on X chain. We could transfer it to C chain so users can swap it on, say, Trader Joe. But then, let's say we make an agreement with a DEX on another chain called DEX chain in the DEXnet subnet to boost farm rewards for Wolfie holders. Users have the incentive to bridge their Wolfie there. When the farm rewards end, we make a deal with another subnet team, HODL chain in the HODLnet, and boost incentives based on which chain you're coming from. If you come from DEX chain, you have a 10x boost, while if you come from C chain, you only have 2x boost. Users are incentivized to bridge from DEX chain, not from C chain. We could know which chain users are coming from because each version of the token actually has a different contract address. Then let's say Trader Joe offers a 20x boost on farm rewards for that token, but only to those coming from HODL chain. Wolfie would now go back to C chain but it has a very different nature, and like different symbol as well, because it's called .c because it came from C chain, that it's called CD because it came from the X chain that came from C chain, and then it's called like this. Liquidity is fragmented a lot. The price are actually very different, and they cannot be precisely the same because arbitrageurs would need to have a pretty instant connection between all the subnets and would need to bridge in real time. So they could, maybe in a couple of years' time when the markets are really heavy on every subnet, there could be, arbitrageurs that make short and long positions and everything just to, compensate every trade. But for the moment, arbitrageurs need to bridge from one chain to the other, and it actually costs a lot of money. So if there's a little difference in price, like 0.01%, maybe arbitrageurs don't have the incentive to bridge towards and back. So it's very complicated, We hope this journey has made clear there's high fragmentation here. And to solve this, we're working on a solution of our own. But in the meantime, please use C chain as the gateway chain. This could simplify the experience a lot. The research that I presented here is a direct consequence of our process that starts back in the Avalanche core ETH node, where we analyzed all the data we can get from the Avalanche network. And we try to squeeze as much data as possible. Once we study this data and learn how to get them from the network, we need to save them as data structures in our databases. We ask ourselves, since this is the data we have, what can we do with it? How are these different data structures related? Is this data influencing other structures that we already have? And so on. When we solve this, we can start designing new features and pages. This process can take from weeks to several months, and it's our core work. And this process has also been tweaked over time as we grew from 7 staff members in August 2021 to 21 now, and aiming for about 30, 40 by end of the year. We want to become the first interface to all things Avalanche for users, analysts, and developers. But how do we do this? We started with X-Chain when Avalanche launched. As a DAG with the UTXO transaction model, we need to represent transactions and tokens using a mix of views from Bitcoin and DAG like IOTA explorers. Transactions are the core concept, and they're organized in vertices. But there's also a special type of transaction, the import or export transaction that directly connects tokens with P-chain or C-chain. With C-chain, the busiest blockchain for now, we really needed to understand how it would add up to the overall architecture and manage the heterogeneity, again, of the different types of account addresses. That's why we released a version that was very similar to the one on X-Chain, though with some adjustments that take into account a different transaction model, from and to instead of inputs and outputs. This is important for us because we want users to have an integrated experience when they can browse through chains following import and export transactions. This is something that you cannot do in any other explorer for Avalanche. Once we had both X-Chain and C-Chain indexing running, Ava Labs released a new update to the Avalanche Go node to allow transferring tokens deployed on X-Chain to C-Chain. That was the first time we seriously thought about tokens at a different level. The thought was this, heterogeneous VM can encode tokens. VMs can be powered by different consensus protocols based on different data structures like chain of blocks, DAGs. Blockchains are validated by subnets, and subnets are like jurisdiction that can have different rules similar to different countries. So we thought, why don't we aggregate tokens from different chains? And that's why we're building the market cap page that is now in beta for a lot of time because we're trying to still finish it. We will evolve this page to show tokens aggregated by subnets, but we already do it from the primary network. As you can see, there's X-Chain, the Avalanche, there's also the C-Chain tokens, and we are already integrating support for subnets. Then there's P-Chain, the last chain to complete the indexing of a primary network, and it has specific types of transactions that are like operations. They have effects on the entire network. For example, when a subnet adds a new validator, let's see, add validator, that transaction is actually reflected on the whole network, on the staking part of the network. And for example, a transaction can also be a deploy, a create blockchain or a create subnet. And so that transaction creates a new blockchain. So we need to reference that. It's the operation chain. So we need to index it in a different way and show it in a different way. That's why we decided to evolve. Sorry about this, but it's a switch. That's why we decided to evolve the address details page to show contextual information, and you can already do it right now. So, for example, when you are on an address, for example, on C chain, you can switch it between subnets, so you can understand that the token, that the address that you're actually seeing, can have different natures depending on the subnet it's in, or the chain in this case. The page will also be contextual. If an address is actually a token contract, we will display specific data about it, along with details about other chains, if it's bridged on other chains or even subnets. So for example, here you'll see that we have the balance, the NFTs. We'll also have an algorithm to predict the NFT prices. And we have all the information about what this token, what project does this token belong to, and then all the descriptions. And then you can see if this is a token, you have the specific tab that is called token. You'll be able to see all the information, the token information about it. And if it's a bridge, you will be able to see all the bridging statistics about it. And if it's a DEX, you will be able to see all the DEX swaps. This is a multi-year process. It's not easy. But for example, if the address has made some import or export transaction, we could actually infer what C-chain address, what X-chain or P-chain address this C-chain address is related to. Because the Avalanche wallet can create different addresses based on the virtual machine it's in. So we can actually show you if this C-chain address has some staking position on P-chain. But this is, this is a sneak peek into the future. And yeah, I already have here the QR code to show you a few our designs. And this is our evolutions also for the transactions. And this is, this is really, simple, and it's what we have learned that works best for a lot of types of transactions, because this works fine both with the accounting model, so from and to, and the UTX model, so inputs and outputs. We're trying to make users understand what's happening independently of what type of virtual machine they're in. Because the virtual machines are just done to optimize some types of operations. For example, maybe a project wants to build an EVM because they have certain needs, and then a project needs to build maybe a Zcash fork because they want to have anonymity. And so we would like to have a unique design that just adapts to all types of transaction models, so virtual machines. And this is what I said before, the bridge statistics page that will be contextual. This is our future as a multi-subnet explorer, and it perfectly fits with our mission to become the first interface for Avalanche users. We are already discussing with all the upcoming subnet deployers to release a first version of their subnet integration. You can see them right now on Avascan. I think we have 4 indexing subnets on testnet and 3 on mainnet. And we expect many more to come in the coming weeks. And 2022, and this is something that I'm saying here and there, could also be the year of our own token, Scan. We would likely be the first explorer to release a token. And I believe Scan could be widely used by subnet teams. If you're one, you can get in touch, and we can talk about how to index your subnet. But if you're investors and want to get first in line in the scan fundraising to support our growth, you can join the Wolves of Avax Investor Collective that has a preferential treatment for scan investment. If you're a whale, a big spender, or are going to fundraise, I'll be happy to introduce you to it. And I'm open to questions now. Thank you. I think I confuse a lot of people with all this subnets talk. If there are any questions, otherwise, we could just grab a coffee out there.
Subnet is difficult topic, and this is
late
afternoon.
Yeah, I know.
Your Twitter. Yeah, share your Twitter. What is your Twitter handle?
This one.
Oh, very small.
Yeah, it's in the footer, but yeah.
Yeah.
It's iJack94. Yeah.
Hello? Yep. Hey, thanks. I'm Dan. We're actually working on music rights, and we build on music rights.
Okay.
Yeah. And we do that on Corda, a banking blockchain, and I can explain why. It's for legal compliance. And we're now exploring to connect this to like an Avalanche subnet. Mm-hmm. Have you looked at interoperability like that as well?
Unfortunately, yes. It's a mess. Because, Corda, it's from R3, right? It's from the R3 consortium.
Yeah.
And so that has actually, I think it has very different rules. And there are examples of projects bridging tokens, so value from one network to another. For example, the FK chain, DeFi Kingdoms, bridge from Harmony to their own subnet and to C chain, and you can use one of these bridges. If we had to suggest something, we would suggest something between Synapse and Layer 0, because they both have something kind of like a liquidity bridging. So you will not actually mint and release the tokens. You will actually only have the tokens in. It's like a liquidity pool, but both sides are one on one chain and the other on the other one, and so it's like lending and then borrowing on the same on two chains. It's kind of difficult, but I think that's the way it works because, for example, Synapse made tokens for the FK chain, and if you come and say to them, please can I bridge AVAX from C chain to my chain, they will simply add support for your chain, but they will use the same token. So, and the same token of origin. So we will not need to have multiple tokens for multiple bridges, because otherwise that's how it works. Every bridge have their own tokens. And this is a mess.
Yeah. So we're looking at this complementarity, where you use the strength of Avalanche and some of the strengths that a Corda can bring, because multiple parties want different things. And thank you for your presentation, because this will come up more and more, because not one chain will win.
Yeah. No, it's interoperability is actually the future, because it's like a big sharding. It's like big sharding, sharding at a crypto ecosystem, crypto industry level. And I know about teams that are trying to have seamless integration with subnets. So you basically, the basic idea is that if you could just let users deposit tokens in your interface, and then all the operations that are there are maybe gasless or something like that, but they all happen on the subnet, because that's really fast, and it's just the deposit and withdraw that you can that happen on the main chain. This is, I think, the best solution. It is also something similar to what L1 and L2 on Ethereum are doing. You deposit, for example, on Loopring you deposit and then you withdraw, but on Loopring you have finality of 1 month or something. It's a mess. and then instead Avalanche has a time to finality of 1 second. So everything is settled in 1 second.
Could I ask one more question?
Yeah, please.
If other people have. If you look at Avalanche subnets,
yeah.
If I'm correct, you can build them either in Go or Rust. Is there a preference? Is there benefits?
I don't know about it. I'm not from Avalabs, but no, I don't think there's a preference. But you don't actually need to code a lot. There's a lot of engineers here that build the subnet code, and you basically need to fork the subnet EVM repo, and yeah, Connor said yes, and you can use it, or you can try your own implementation by building your own plugin VM. But for example, this is what Zepa Labs has done. Last week, they released a plugin VM for zero knowledge blockchain, and but that is actually pretty difficult. You know, I think it took 6 months for him to do it, and but Subnet EVM is actually, I think, 5 hours in deployment. Is it something like 5 hours one day to deploy everything?
It's very quick.
Yeah.
That's good. And we're also software developers. But yes.
What?
We're also software developers.
Ah, okay.
Yeah.
Any other question about subnets?
We are slightly behind the schedule.
Okay. Okay.
So if you have more questions, please add him on Twitter, and DM, please open your DM.
Yeah, I've also.
Cool. Yeah, so we will keep this during the break a little bit so that you can get his Twitter or Telegram or Discord. We are slightly behind the schedule, so we will have around 5 minutes break. Then we will go for the next session about Metaverse and Web3 gaming. See you in 5 minutes.